aircraft manufacturing, tooling is the backbone that turns design intent into real structure. Without precision tools, parts can't be held, aligned, or positioned with the repeatability needed for airworthiness. Good tooling ensures that complex shapes like fuselage barrels and wing skins integrate correctly every time and without costly rework. And it supports consistency across the entire production run. Advanced tooling is what makes thousands of parts fit together seamlessly in an airplane that weighs hundreds of tons. Jigs and fixtures sound technical, but they are simply work-holding devices that lock a part or guide a tool so operators and machines can cut, drill, or assemble accurately. A jig helps guide operations like drilling or riveting, while a fixture holds the part stable in a precise orientation. They do the heavy lifting of accuracy for us so that workers don't have to manually match every hole or surface. These tools enhance productivity and guarantee that every structural element meets tolerance requirements. Fixed tooling is built for one specific task or part. It's rigid and extremely accurate, but costly and slow to change. Flexible tooling, on the other hand, can adapt to different assemblies or part variations, saving time and cost in mixed or low-volume production. In aircraft factories, where part numbers and revisions change frequently, having the right balance between fixed and flexible tooling boosts efficiency and minimizes downtime when design updates occur. Modern agile tooling even incorporates quick adjustments or modular setups to keep the line moving. Big aircraft pieces like wings and fuselage sections demand serious tooling, giant fixtures and jigs that support these structures during forming, drilling, and final mating. These tools often span tens of meters and must maintain extreme rigidity so that panels, spars, and skins align exactly as designed. Whether it's a traveling fuselage jig or a wing assembly fixture, the tooling defines shape and geometry before systems and skins are added, making it indispensable for high-volume, high-precision manufacturing environments. Tools don't stay perfect forever. Wear and tear change dimensions, alignment, and reliability, so aerospace tooling must be monitored, cleaned, adjusted, and recalibrated regularly. Calibration ensures that the tooling still matches design tolerances, and worn jigs can cause misalignment, stress buildup, or quality issues later in assembly. Manufacturers schedule tooling checks just like aircraft inspections to detect deviations early and prevent costly defects down the line. The future of aerospace tooling blends physical fixtures with digital precision. Laser tracking, metrology software, and digital tooling systems can capture dimensional data and guide assembly virtually before anything is bolted together. Laser trackers and digital models reduce guesswork and allow virtual simulation of final alignment, catching errors before they become physical problems. This digital thread not only improves accuracy, but also feeds back into process improvement and reduces wasted time and material on the factory floor.